Hello, I will be talking about reflections. Reflection is typically assigned, you typically think about the light if we are talking about reflections, but reflections are also primarily used to model a situation like this. You have an object like a ball, this ball hits the floor, this is the floor, okay, and we are interested in this moment. Well, when the ball is here, I am simplifying this picture, so this ball has no spatial size at the moment. It's just located here as the point. In the moment of hitting the floor, and this is the first thing you have to be careful about, this is the velocity vector of this object. So you can see that it actually goes underground. Simply because the velocity of the object just before hitting the floor is pointing down. Okay, it was falling down, it was flying down, not vertically. It's there is some angle here which I will call alpha here. Okay. So in the moment when it hits the ground, the velocity points are more or less downwards. After bouncing off, this velocity will change and will point here. And we need symbols, so for the original velocity it was v, for the new velocity it's v prime. We had a similar situation in your very first portfolio exercise, the Escapa game, in which you actually had some objects that were bouncing off from the floor, from the ceiling, and from both walls. So after this exercise, you should be aware that v prime, if, first of all, if v is xy, can you check please if this formula is still visible?
Yeah.
Okay. If v is xy, then v prime will be, x doesn't change in ideal case, in the case of mathematically ideal bounce off. So it is still x, and this velocity in the y direction will change to opposite, so it's minus y. Okay? So that's a very simple maths for a reflection from ideally horizontal surface. Similarly, you could apply it for vertical surface. Okay, we have velocity here, we have the final v prime velocity here. The difference would be that in this case it's y that doesn't change, it's still going down, but in the x direction this will change, so v prime would be minus x y. But what we are really interested in, because in a typical game it would be a rare case, maybe in Escapa, okay? But in more realistic games, the surfaces you are using will be very much different angles. So they may be neither horizontal or vertical, it may be something like this. Okay? The key to do anything is the normal vector. I don't mean here normalized vector, so please note the difference between normalized and normal. Normal vector is not just normalized vector, it's first of all a perpendicular vector to the given surface. It's the standard way of defining the slopes or the facing of a surface in both 2 and 3D graphics. So in this case, we also have the normal vector here, which is pointing ideally upwards in case of a horizontal or something like a floor. For the ceiling, the normal vector will be pointing down. For the wall like this, behind the whiteboard, it will be pointing this way. For this wall, it will be pointing this way, and so on. And of course, for anything that is sloped, the normal vector will point perpendicularly, showing you the way in which the surface is facing. How can we calculate v prime having a situation like this? Now, when you perfectly know, I hope, how dot product works, you should be aware that this thing here, which I will not call it, I will leave it as an anonymous vector for a moment. This vector is nothing else but v dot n. Okay, it's an old rule of casting vectors, right? So it's actually always like this. If you have a vector, one vector, and a direction defined by the normal, then the cast of this vector in the direction of the normal is given by something like this. We actually should also multiply this by n. Why? Because v dot n, just v dot n, is a dot product, it's a number. Okay? I want to find this vector, so what I need, I need a vector. A vector in this direction, never mind that it is pointing downwards and is upwards, I will explain about this a little bit later. But by multiplying this number by a vector, I get the vector value. Okay, so once again, v dot n, this is a number, multiplied by n, this is now a vector. A vector of this direction, so this is the vector somewhere inside this line. Okay, it has the length of this. Why? How do I know that this has the length of this? I know this because n is normalized. Okay, normal is perpendicular normalized vector, so its length is 1. So by multiplying this number by the normalized vector, I don't change the length of this thing. So this is the length of the vector. So we know the length and we know the direction. What else can we know? Very importantly, we can also know that this v dot n is this distance here. Now, if you don't trust me that this is it, okay? Just think, v dot n is length of v, length of n, cosine. Now, we know that n is the normal vector, so its length is 1. So, what it is equal v cosine alpha. If you look at this picture, alpha is here. Okay, we are looking for this thing here. So what is cosine alpha? Cosine alpha is the adjacent side divided by this. This is v. So this is exactly what we are looking for divided by v. It's this. Okay? So now it is not trusting me or not. We just know that this value is exactly this vector here. Few words of explanation about the directions, upwards and downwards. Okay? How it works. If you look at this vector and this vector, you can see that they are two different directions. Okay? One is pointing somewhere there, the other is pointing somewhere there. Just knowing this, what can you tell about the dot product?
They don't meet.
They
Don't meet.
but the dot product will be what kind of a value we should expect? Negative.
Yeah.
Negative. They are pointing outwards, so dot product is negative. So this is a negative number. We don't know exactly what kind of a number it is, but it is negative number multiplied by normal vector. A vector multiplied by 1 is the same vector. A vector multiplied by something greater than 1 is a longer vector. By something between 0 and 1 is a teeny tiny vector, okay? But the same vector multiplied by a negative number will be a vector pointing the other way around, okay? So if this is a negative number, this means that this vector is pointing here. And now I will produce the formula for the reflection for V prime using what we know so far. I need a little bit more space here. So, my V prime, what is V prime? V prime is here, but I also have velocity here. Velocity plus, I will take this vector and I will draw it again here, but the other way around, upside down, okay? So what is this? This plus this, it's V minus my vector created here. So I will not do the plus, it's minus V dot n times n. 1, I will add this vector once again. Sorry, my drawing is terrible. I will make it a little bit better. But if you draw it properly, you will see that V prime is a symmetric reflection of V. Alright? So if here we have some direction, some distance, the same distance measured here will give you V prime. So I'm taking V, this vector, okay, subtracting this vector once and the second time, 2, and tada! This is the formula for reflected vector. This formula will work for whatever surface we have, and in a few moments we will use it in practice. So that's the theory for the next week test, and in the next video I will show you how to solve the practical problem. Thank you.